are soon to launch in Ethiopia, but this was kind of phase 0 of our business. We have completed our standard operating procedures and are deploying them across these first 3 plants. We've onboarded two partners. One that will be leading the maintenance aspect of our business. It's a company called Interkel that's based out of Nigeria and has 30 years of experience in construction and infrastructure maintenance, as well as Via Technologies, which is a portfolio company of Econet and Liquid Telecom, and they've been helping us develop a fully integrated ERP solution and tech solution for our entire business. And before I move on from partners, I do want to say, mention our partners in Skoll Foundation as well as Elma, because they were the two funding partners and thought partners that helped us get off the ground and really believed in this business from its earliest stages. And in terms of our next phase of plant deployments, we've ordered 7 plants that we expect to be on the ground in the next few months. And then lastly, just to provide a more detailed picture of where we want to be in the next 2 years. So we'd like to build on the momentum in our first 3 markets. As I mentioned, we will be expanding into other markets, but we do, want to ensure that we are making a meaningful dent in the oxygen gap in all of our markets. So I think beyond the next 2 years, we will be aggressively expanding outside of these first 3 markets. Majority of these first 2 years will be focused on these markets, and you'll see some of these kind of large projections in certain time frames, and that's because we do have for every number you see on here, there are partners both on the customer side as well as the franchisee side. So some of these larger numbers are government opportunities we're pursuing, or are opportunities with groups of hospitals in these markets. And again, as we want to get to 105 years, if we can reach that goal or far exceed it earlier, we're happy to. But in the next 2 years, we do plan to get to about 75 plants across 6 to 8 markets. And that's it. No need to go through these slides. And thanks everyone for your time.
Thanks, Efison. We have a question in the chat. If you would like to respond, if you see it, it's from Bushan. Bushan, would you like to talk to your question?
Thanks, Marcella. So the question is pretty straight. I think you talked a lot about the plans for Africa, certain countries, and expanding as well again in Africa. Could you, if you have any other plans for other regions, particularly Asia and Latin America, or if you could refer us to similar business ventures or partners, which would be useful for us. So just if you know any additional information on that front. Thank you.
Sure. I mean, you're right. We are focused on Africa, but I think it might be good to take this conversation offline, because as I mentioned, we intervene across every aspect of the value chain, and our goal is to be helpful in mainstreaming oxygen where it's needed. So we kind of do have these four offerings that I mentioned, but we've looked at actually Southeast Asia as well. So I can actually shoot you, or if you drop your email in the chat, happy to reach out and have a follow-up conversation.
Thanks, Efison. We can also share your email with participants in case there are further questions outside of the session. If that's okay.
Sure.
Thank you. So we are moving on to the next speaker, and that's Jim and Sarah from Build Health International. Jim, are you online?
Yes. Good morning, good afternoon, good evening, everyone. Thank you for having me. I'm just going to really talk specifically about PSA oxygen plants and the challenges in installing them correctly and maintaining. In the if you go back one slide, please. In this slide, you see the university hospital in Mirbelet, Haiti, that we designed and built with Partners in Health. This plant was a very large PSA plant, was installed in 2012 and has run 98% of the time since then. We have learned a lot from maintaining that plant, as well as many, many others. Unfortunately, this is not the case for many plants in low resource settings. Next slide, please. I really want to focus on three things. First, the correct plant for the application, the type of plant and the capacity of the plant. Second, are site-specific electrical and environmental factors that are really not well understood by funders or many organizations doing the procurement. They're generally understood by the manufacturers, but their job as the manufacturers is to build and sell and install these plants. So it's really a gap. And the third is key factors for successful maintenance and plant longevity, which is very, very challenging in general, but very difficult in many countries and less industrialized countries where there's not a lot of industry or mining, so there's not a lot of service parts or technicians. Next slide. First thing is, I just want to differentiate that there are a number of different types of plants and configurations. The PSA technology, or VSA, carries through for all of them, but there are multiple configurations, and which configuration you go with that really is driven by budget and by the need of the facility. If you have piped oxygen, that is, which we're huge advocates, and we're currently just beginning a study on the efficacy of piped oxygen versus cylinders, something we've known for quite a while, but makes a huge difference in patient outcomes. But if you have piped oxygen, you don't necessarily need to fill cylinders. And the blue compressor you see in this photo is a high pressure cylinder filler, which is in many ways the Achilles heel of the PSA plant. It is very expensive. It requires frequent maintenance and very expensive parts. So one thing to consider is, do you need to fill cylinders, and if so, how many? One of the trends we're seeing and doing and really pushing is, wherever possible, to flow oxygen at a low pressure through piping and not fill a lot of cylinders, just fill enough cylinders to serve as a backup. Next slide, please. I'm not going to spend a lot of time on this. This will be available to people, but I just wanted to give an idea of different plant configurations and costs and sort of pros and cons. What I'm calling the RICS, who is one of two manufacturers of the high pressure cylinder filling compressors, this adds significant cost and complexity to the system. Often it is very necessary, especially if you're supplying cylinders to other facilities, but it's something you need to be aware of. We are finding that we can do oxygen piping safely at much lower costs than in the global north. And these costs range really between as low as $300 to $500 or $600 per bed in hospitals. So it's really something that should be considered more often because this can really simplify your plant. Next slide, please. Accurate sizing of the plant is critical. Obviously, if it's too small, there's not enough oxygen for the population. And also, if the demand for oxygen exceeds what can be produced, the oxygen purity can be impacted. But also, if the plant is too large, there's also problems. Not only do the capital costs greatly increase with the size of the plant, but your preventative maintenance costs really go up. And it's something you have to think about, especially if you are funding a plant for a hospital or NGO, how they are going to afford to do the maintenance and spare parts for that. Also, the larger the plant, the more electricity is used, and that often is in the form of diesel fuel. I just gave an example of a 235 liter per minute plant versus a 580 liter plant. That difference in electricity could be 12 to 23,000 kilowatts per year. And we typically figure if you're providing electricity through diesel generator, which is often the case in low resource settings, you could be 50 to 65 cents US per kilowatt hour. So this could be $10,000 or $15,000 in cost. Next slide, please. One of the things that's often misunderstood and also does not get enough attention from funders and governments or hospitals doing the actual procurement is the site-specific electrical factors. Time and time again over the last year, we have seen plants that have been ordered for hospitals where the electrical system has just not been vetted. PSA plants require robust, large electrical supplies. Many hospitals don't have the infrastructure, or the infrastructure is just too degraded to support these. Reliance on the local utility grid can be very problematic. People often assume that if the grid is present, they can run a PSA plant on the grid successfully, and that is not always the case. They also think that it is only an issue of voltage, and that is not the case. The issues of power quality extend way beyond voltage. An AVR, which is an automatic voltage regulator, do not necessarily fix these issues. There are some issues that an AVR can address, but because it's a mechanical device that responds, there's a lag time. And depending on the power quality, sometimes AVRs can't address it, and they can't address issues of frequency, fluctuation, or harmonics. The only way to know what power quality issues you're dealing with are to use a power data logger on the system for a period of time, a minimum of 48 hours. So that's attached. Can people hear me okay? This is, we had some background noise. So a data logger is a critical step that's rarely taken. It has to be installed, and it records and measures all the power quality issues that are not going to be picked up in any other way. It's not a particularly expensive device, but it's something that needs to be done by a qualified engineer or electrician. And it's how we start any survey or assessment. Next slide, please. Typical sources of electricity, the utility grid in low resource settings are rarely stable. And again, this isn't just an issue of voltage stability. It's frequency changes really create havoc with big motors and really limit the life. And surges and spikes also affect the computers, the PLCs that run PSA plants. We see a myriad of issues with touchscreens on PSA plants losing their memory or losing the programming. Often those have to be sent back to the manufacturer to be reprogrammed. Diesel generators, when properly sized and maintained, will give stable electricity, but the high cost of diesel fuel and keeping those generators running in low resource settings can be very problematic. Also, if the generator is not sized properly, that can also be an issue. Solar PV microgrid, properly sized and maintained, will give very stable electricity and requires very low maintenance. It has to be used in conjunction with a backup generator, but capital costs and funding are a huge barrier. We have PSA plants that are running completely on solar where the generator is only for emergency backup. It's a great way to do it, especially in sub-Saharan Africa where there's so much sun, but capital costs and funding those really are challenging. Micro hydro grids, where you're using a small dam or capturing a water source, are a very effective way of supplying electricity, but it's really rare to have a convergence of all the factors you need for successful installation for those. Next slide, please. When we're talking about clean and consistent electricity, the electrical infrastructure in the hospital or plant is really critical. And so often in low resource settings, these photos are typical of what we see. And this is a result of many factors of lack of funding, lack of resources, brain drains, and lack of engineering in these countries. But it's real, and the electrical infrastructure has to be addressed up front, or the plant is just not going to be stable. Next slide, please. I won't spend a lot of time on this, but this is just talking about some of the distortions and impact of the harmonics and phasing and understanding how the voltage works. This will be included in, and if people have specific questions, I can answer this later. Next slide. Ambient temperature, especially in tropical countries, is again, a high ambient temperature is something that's really not paid enough attention to. Especially in tropical countries at low elevations, you have extreme temperatures, and heat really degrades the performance and the longevity of these big motors and compressors. This is an example of an installation in Haiti where there wasn't adequate ventilation. The two wall fans were added. Those didn't do it. The floor fan was added. That didn't help. This is a plant that is constantly breaking down because of the heat. Next slide. Another important factor that's overlooked is altitude. When you get into countries like Kenya, where you can have hospitals at altitude of 6,000 or 7,000 feet easily, you have to understand that the generator and the components of that generator have to be sized for that altitude. Really over 300 meters, 1,000 feet, you have to start adjusting the size. So a plant at 7,000 feet, we're working on plants in Kijabi, Kenya, which is that elevation. You're losing 30% of your compressor output, and that has to be compensated for. In addition, high humidity is another factor, and you have to configure the plant to be ready to take air, very humid air, and dry it. So often we add external dryers to the plant, or we specify that for the manufacturer to add those in very humid locations. Again, if you have this information and you ask the question to the manufacturer and you give them weather data, they can add additional drying to the PSA plant, but most people don't know to ask these questions. Next slide, please. Some ventilation best practices. The main compressor, which you see in the background of this container, should be directly vented to the outside. This compressor, which can be 25 horsepower, 50 horsepower, 100 horsepower, gives off incredible amounts of heat, and that should be vented directly to the outside. And again, the manufacturer can help you size that, but it has to be done and it has to be planned. Just putting a fan in the room isn't going to do it. You're also going to need a secondary room exhaust and a certain amount of fresh air in the room as well. And if you're in a very dusty and dry, dusty environment, the makeup air that's coming into this room should be filtered. If you're building a building to house or going into an existing building to house the PSA plant, insulation under metal roofs, under sort of the typical tin roof, can be very helpful in just keeping the temperature of the space down. Air conditioning is a real alternative in very hot climates, especially for smaller plants and containerized plants, and something we think about regularly. Next slide, please. The challenges and repairs of maintaining the plant once you've successfully installed it are numerous. Spare parts are very difficult to source in many locations. It can be very expensive. Again, in more industrialized countries, in countries with mining industry, parts for at least the major compressors and other general sort of mechanical parts are more readily available. But if you get into countries where there isn't that kind of industry, and there's very low resources, it can be very, very difficult to get parts. The high pressure booster compressors, which are really made by only about 3 companies, perhaps a few more in the last few months, in the world, are rarely stocked and very, very expensive. Again, these are the booster compressors, which take the oxygen, compress it from 50 or 100 psi to 2200 psi or more for filling cylinders. When ordering a PSA plant, it's very important to include what we would call consumable supplies. Or the compressors require special oil from the manufacturers. And that is something that is almost impossible to come by in many settings. So various different types of motor oil are used, which really degrade the life of the compressor. Filters, not just, there are multiple filters on these units, and those need to be changed regularly. And also they, especially the high pressure compressors, require rebuild kits every 8,000 hours, which is usually 9 or 10 months. The high pressure compressors need to be rebuilt, and that's a complicated job, but it also can be a kit that costs $5,000 to $12,000 depending on the model. In addition, parts that frequently fail or have limited life expectancy, for example, solenoid valves have to be replaced every couple years. Most oxygen sensors are designed to function for about 2 years. So those should be included. Lastly, looking at alternative suppliers for non-proprietary parts. One of the things we do as an organization is we are always looking where we can buy non-proprietary parts at a lower cost. And sometimes we see, especially on the high pressure compressors, a markup of 300 or 400% on the parts. So one of the things we're trying to find funding and time to do is to really research this and create an open source parts list for NGOs and ministries of health to be able to do purchasing, but that's in the future. Next slide, please. In maintaining and keeping plants up and running, there's 2 distinct work streams. There's the daily and weekly maintenance, which needs to be done by staff who are running the plant. The plant, when running, needs to have a trained attendant there supervising it, making sure that alarms aren't going off, and someone who knows what to do when there's a problem. In addition, there's really weekly maintenance that needs to happen, and it has to be done on a regular schedule and tracked. Filter and oil changes can be done by the plant operations staff if they're trained and supervised, and if there's a sense of accountability and ownership. Major service or repairs requires trained techs, and the availability is really country dependent. This is something that is widely misunderstood, especially in sub-Saharan Africa. Often there is a manufacturer's representative of the company that makes the main compressor, Kaiser or Atlas Copco. They are not necessarily the right people to service the oxygen, the PSA plant. They understand one component of the PSA plant. So putting reliance on them to keep the plant up and running is not necessarily a good plan. There's a few manufacturers in Africa, primarily in South Africa, but they have limited resources to travel. And if you're asking them to travel too far or in a country where they don't have a regular presence, that is problematic. In addition, many people say, well, we have trained biomed techs. They can do this. That is not necessarily the case. This is not work biomed techs are trained to do. You would not, these are big industrial machines. These are not, complex electronic monitors or the types of equipment that many biotech work on. They are often great candidates to be trained on this and have the basic skill set to learn, but you can't assume that biomed techs can do this work. Service agreements with plant manufacturers are complex and not always an effective answer. Again, if the manufacturer doesn't have a true local office, the response time can be very problematic. We see when plants break down, often they stay broken down for months and months because, again, it typically requires a minimum of 2 visits to repair the plant. First, the service company has to go and diagnose what the problem is and order parts. The parts can take a long time, especially clearing customs, and then they have to go back and install and recommission those. Next slide, please. We recently, with funding from the DAC Foundation and through the Every Breath Counts Coalition, did an assessment in Malawi of the 7 non-commercial plants. We found 3 were functioning well. 1 was functioning but in need of repairs, and 3 not functioning. There are many plants like this, and even though there's been a lot of funding in the past 16 months for surveys and tools, there is no clear document that is in the public view which shows where there are plants installed and what their level of functionality is. And it's going to take a long time, although the Global Fund is trying to get new plants into the system as quickly as possible. This is going to take a long time, and we are urging people to try to fund finding existing plants that can be repaired and repairing them. There's also a portion of plants that have been funded and installed, but never fully commissioned and never run. Again, this is a case of funders and people doing the procurement not dealing with all the requirements to have that plant up and running. Next. So just a summary of, sort of planning for longevity for a PSA plant, sizing the plant on actual demand, not just the funding. Even if you have additional a budget, you don't necessarily want to oversize the plant. Plants can be done modularly as well in steps. A comprehensive site assessment before a plant is ordered with qualified engineers is absolutely critical, and this is rarely done. You have to understand the environmental conditions the plant's going to go into and the details of the electrical system, not just that there is electricity at the hospital, but what is the quality of that electricity and how is it going to be connected to the plant. You can't generalize about this. You have to measure it. You have to have qualified people do it. Especially when you're connecting to the grid, there are strategies to protect the plant's compressor motors, the PLC, the touch screens from power quality issues. Again, you need qualified engineer to advise you on those and help specify what to include. The manufacturers, again, can include surge protection and UPSs and many things like soft start, which cuts down on the surge when the major compressor starts, but you have to be able to ask for it and know to ask for it. Don't negate the issues of ventilation and humidity. There has to be training for local attendants who will do the day-to-day maintenance, and that is again something that's overlooked. You can't do that with a 2-day training from the manufacturer. It'll help, but it's not going to be enough. It's going to take regular visits from somebody training that staff and have the human resources capacity in place and commitment from the hospital or whoever's going to run the plant. And often that requires funding. And then lastly, budget and procure extensive supply of consumables and spare parts when you purchase the machine. Again, in some countries, this will be less of a requirement. In other countries, it's absolutely mandatory, and you have to know what you're getting into in each particular country. Next, I think that's it.
Yes, Jim, thank you very much. I'm going to pass on the word to Dave from our TAP department so we can close the session because we run out of time.
I'm sorry.
Thank you, that's okay.
Thank you, Marcella, and big thanks to Jim and Epson for a really richly informative session. I think you guys have given us a whole new respect for the complexities of PSA implementation and upkeep in the countries that we're supporting. Just to say though, I think you've also, in this respect, also fleshed out for us the fact that these are practical things that can be addressed. They need to be addressed. They're part of health services and health systems. It's not rocket science, and they're things that are going to be fundamental to making sure that these investments are sound. And I think you heard a lot of in the chat and some of the questions and comments, a lot of enthusiasm for this level of detail and information, and wanting to take this forward and ensure that we can use this to provide oversight of the implementation ahead and helping our country partners to make sure the investments stay sound. I know that there are a lot of additional points of follow-up and discussion and questions. Unfortunately, we have to have a hard stop on this session at this point. So I want to give you another big round of thanks and applause, and thanks to all the grants management colleagues for having taken precious time away from C19RM to join this this really important session. So thank you again, and have a great day, everyone.
Dave, I just mentioned that you want to do a Q&A session in the future because I'm sure I raised more questions than I answered. Happy to do that.
Super, thanks. And Epson, we'll circle back to both of you guys. I do think that that's something we might want to consider in the next week or so. So thank you for the offer, and thank you again for your time today.
No problem.
Thank you.
David. Thanks, Jim.